Hello, everybody. Hello, Naruvirandarki. Hi. Very good evening to all of you. I hope everyone is doing fit and fine. Am I audible, visible? Andariki cheppandi okasari. Hi. Good evening, Andariki. Good evening. Good evening. Yeah. Yes. Good evening. A very warm good evening from my side. ఈ సెషన్లో we are going to cover in the last class అంటే last live లోరా thank you so much Parimala. Yeah, after a long time 1 week తర్వాత we are going to this live, right? I'm fine అందరికి I'm fine. Very good evening. Yeah, there was a break. I agree. Yes. Okay. Good evening. Great. So in the last class we discussed about your magnetic effects of current. Dintlo kuda we talked about Ampere Circuital law, Biot Savart law, questions and applications ade kada. Although it was supposed to be one short lecture kani due to the time constraints we could not complete it in one shot. Kabatti ee session lo we are trying to finish that chapter. That chapter ante oka 2-3 formulas unnai ade. Yeah. Maitri, thank you so much, Maitri. Okay, I think, I'm really glad to hear that students are loving me so much, It really melts the heart, Re. Andariki. Thank you so much, Andariki. Thank you so much. I'm really delighted. Teaching profession lo unnappudu what did you earn ante this is what I have earned. Okay, the love of you guys. Yes. Yeah. Great. No, Seraphic, I did not miss your text. I'm watching actually. Sorry. So start chedam andariki. If you don't have any problem we can start with the discussion. Hi. Chuskondi. Whatever we discussed till now, recap antaru ade kada. Yes, recap lo we talked about Biot Savart law ade kada. Yes, we talked about your Biot Savart law. Sir, what is Biot Savart law, sir? Biot Savart law simply states small chinna magnetic field dp is equals to mu naught I divided by 4 pi into dl bar cross r bar divided by r cube. Ide kada. Yes, so this is your Biot Savart law. Dan tarvata we discussed some of the questions based on that. Okay, we discussed some of the questions ante enti sir? Magnetic field due to semicircle, magnetic field due to arc of a circle, magnetic field due to infinite wire. Ade we also talked about magnetic field due to a finite wire. Ide kada, right? Yes. Yeah. Very good. Yes, dl bar ante small length, chinna length. Then we talked about Ampere Circuital law. Dan tarvata we also talked about solenoid, and also after that we talked about toroid. Gurtunda? Yes. So we also talked about toroid and other. We talked about everything. Ippudu we are going to see an important concept. Force on a moving charge placed in a magnetic field. Ante enti sir? That means Just a minute. Okay. Okay. Hey, don't spam, re. Hey, don't spam. Good evening, Andarki, good evening. Chusko. I have a uniform magnetic field. And enti, sir, let us say this is the direction of the magnetic field. Magnetic field and enti, you have a machinery, you have a machine. In that machine, you are creating a magnetic field, and the magnetic field is going into the plane of the paper. Magnetic field and telusa, you can imagine there is this north pole and south pole is there behind this board. Okay, north pole, south pole, all the magnetic field lines, they are going from north pole to south pole. Ade kada? Yes. So this is the direction of magnetic field, sir, and it's a uniform magnetic field. Ide me syllabus kosam magnetic field is always uniform. Variable magnetic field ante it goes in the category of JE. Ade kada? Okay. Chuskondi. So I'm placing a charge idena charge Q, I'm placing in a magnetic field. Emaitadi, sir? Nothing will happen. Nothing will happen if you just place the charge in the magnetic field. Enduku, sir? Because this charge has no speed at all. Mari em cheyali? You do one thing. Do you remember something? Yes, very good. So, sir, when you're hitting this charge with a speed v, what was expected? Now, expectation and when I'm hitting this charge with a speed v, it should go straight. Ade kada? It should go straight. Kani, it is not going straight. Some magic is happening, ra. When I hit it, it is automatically converting into a circle. And moving round and round. Okay. So when I hit it with some speed, it is actually moving. Ante speed is changing. Change in speed and acceleration. Idera, hey, chusko. Even if the direction of the speed and velocity it is changing, there must be the acceleration. Sir, velocity lo change unte acceleration untundi. Acceleration unte force untundi kada? Yes. Ante a charge placed in a magnetic field and you give some speed to it, it will experience a force. Value enti ante, sir, formula. Ee force ki formula ante F bar is equals to Q is the charge value. Chuskondi andariki. Q multiplied by V bar cross B bar. Sir, what is V bar, sir? Sir, V bar ante velocity of the charge. Ade kada? Yes. V bar ante velocity of charge. Whatever velocity you are giving to it, ade ante V bar. Good evening andariki. Yes, good evening. B bar ante entira? B bar is the magnetic field. Andariki chuskondi. It is not a simple multiplication. Rather, it is the cross product. Cross product and the telusara. Cross product, sir. Cross product ante the value of A bar cross B bar, sir, it is simply equals to AB sin theta, and at the same time we write n cap. N cap ante entira? Imagine ide na vector A bar. This is my vector B bar. Angle theta antaru. Take your 4 fingers in the direction of A bar, curl them, A bar cross B bar is coming out of the plane. Ante kada? Yes, the direction of the force also matters a lot. Andariki chuskondi. It is not only the value but also the direction. Direction gurtupettukondi. Direction ide chala important ra. So let us imagine, sir, B bar ante into the plane kada. Ide na B bar. V bar, sir, V bar is to the right. Choose kora initial velocity V bar. V bar is initial velocity, whatever you give it. Okay, sir, V bar cross B bar. Okay, V bar ante right side lo, B bar is into the plane. Do the cross product ra. When you do it, your force is coming upwards. So after some time, koncham samayam tarvata, this charge is coming here. And the speed is here, V bar. Idena B bar, V bar cross B bar. Teeskondi, this is your direction of force. Yes, so your force is, your force is in this direction. Idena force F bar. Sir, force, velocity, force, velocity, force, velocity. Force and acceleration. Yes, sir, acceleration, velocity, acceleration, velocity. There will be change of velocity. Acceleration and change in the velocity. Yes. Very good. So after some time, your velocity will be something like this, in this direction. It will keep on changing. Choose ko idena V bar. Eppudu magnetic field is inside. So V bar cross V bar ante force will be in the idena F bar. And it will make a circular motion. Andariki చూసుకోండి. చాలా important. చాలా important, sir. Force is equals to Q into V bar cross B bar. V bar cross B bar ante A bar cross B bar laga undadu kada. Yes. So you can simply say, sir, it is equals to Q into V into B into sin theta. Theta ante enti ra? Theta is the angle between V bar and B bar. Ee case lo chudandi. V bar towards the right, B bar into the plane, angle between them ante simply 90 degrees. Ade kada? Yes. Sin theta, theta is 90, sin theta is 1. So your net force F is equals to Q into V into B. Understanding andariki? Yes. So let me just quickly revise everything. When you place a charge into the magnetic field, nothing happens. Okasari you are giving the speed to it, yes, then it will move in a circle. Ade kada? Yes. Force gurinchi cheppandi. Force entara? Force is equals to Q into V bar cross B bar. V bar cross B bar ante direction kuda vachindi. Ede kada? Yes. Very good. So your force has direction as well. Hey, this force has direction as well. So what is the direction? Always directed towards the center of the circle. Chudandi, ide na center. The force is something like this. Koncham samayam tarvata, like this. Hey, this is my force. Directed towards the center. And centripetal force. Hey, Gurtunda, in circular motion we discussed something about a force that is always directed towards the center. What did we call? Centripetal force. Ide kada? Very good. Ante ee case lo మీ దగ్గర ఒక magnetic field ఉంటే you place some charge into that magnetic field. This is my charge Q giving with some speed V ra. Automatically it performs your circular motion. Ante circular motion ante there must be a force towards the center. Please go and watch circular motion lecture. Akkada I have told you there must be a force directed towards the center at all the times. Then and only then circular motion is possible. Ee force ki pair ante centripetal force. Ade kada? Yes. So sir, ee case lo your magnetic force on a moving charge. Magnetic force is acting as a centripetal force. Ante this is my magnetic force Q, FB. Charge Q, speed V. Cheppandi, sir, force enta, sir? Magnetic force is equals to Q into V bar cross B bar. Ide kada? Yes. V bar cross B bar. VV sin theta 90 degree. Ante directly Q into V into B. V is for velocity. Gurtupettukondi. Some students misconfuse and take this V as voltage. No, it's not voltage. Okay, it's velocity. Andariki. It's a velocity. Okay. So sir, this is my magnetic force. Kani it's a centripetal force kada? Centripetal force unte oka formula untundira. What is the formula, sir, for centripetal force? There is some formula. mv square by r. Yes. Ante this force is nothing but centripetal force. Ante its value must be equals to mv square by r. R ante endira? R is the radius of the circle. Ante this is the center. This should be my radius. Ade kada? Equate cheskondi ee rendu equations ni cheppandi andariki. So Q times of V times of B equals to mv square by r. So sir, VV gone? Yes. send r that side, qb that side. So sir, radius is equals to mv divided by qb. Other chala important result. Very important result. Your radius is equals to mv by qb. M ante entira? M ante mass. What mass, sir? Whatever mass of the charge you are taking, ఏదైనా mass తీసుకోవచ్చు. V ante velocity. చూసుకోండి, this motion is circular, కానీ the speed is same. It's a uniform circular motion. Other UCM ra. That's why your speed should remain the same. Q ante charge. And B ante magnetic field. Ekkada everything is in your hands ra. You can take heavier mass, you can change M. Similarly, you can change the speed also. You hit it slowly, speed will be slow. You hit it fast, speed will be fast. Q kuda charge da. You can give it more charge, you can give it less charge. Similarly, your magnetic field B also. Increase magnetic field, decrease magnetic field. Ante ee nalgu expressions they are in your hands. Ante the radius is completely in your hands. You can change it. If you want, you can increase it. If you want, you can decrease it. Ade kada? Okay. Very good. Ippudu I want to discuss few more terminologies with all of you. Andariki chuskondi. So now let us talk about time period. Yes, time period. Time period ante chudandi andariki. So let us talk about time period. So this is my magnetic field. Sir, the magnetic field is into the plane of the paper. In 90% of the questions, magnetic field is always into the plane. Okay, all of you. So this is my charge now. Idai na charge Q. Charge Q moving with some speed V. Close your eyes, feel it. Sir, whenever the magnetic field and charge and speed is there, circular motion. Yeah, circular motion. And this charge will complete a circular motion, something like this. So this is the circular motion. Radius entara eppudu calculate chesinu kada cheppandi andariki. Radius is equals to m into v divided by q into b. You know all the four terminologies ra. Ide kada? Yes. So this is the radius. Yes, Vikshita. Yes. So this is the radius. Ippudu time gurinchi cheppandi andariki. Time ante entira? Sir, total time is equals to total distance traveled divided by speed. Ade kada? Time is equals to distance by speed. Andariki cheppandi. Sir, time is equals to distance cheppandi sir. Distance ante total distance. Total distance ante circumference of the circle. 2 pi r. Yes. Sir, distance is equals to 2 pi r divided by speed is v. Ide kada? So this is the total time. Cheppandi. Sir, time is equals to 2 pi into r value antara. R is equals to mv by qb divided by speed is v. Ekkada v gone. Ante total time is equals to 2 pi m divided by qb. Ardhamaindi kada? Sir, circular motion unte we discussed some properties. What did we discuss, Ray? What did we discuss? We were talking about angular speed also. Gurtunda? Speed and angular speed, sir, there is some relationship. What is the relationship, sir? Sir, V is equals to R into omega. Hey, you remember this? Yes. Cheppandi. V ante entira? Velocity is equals to V. R ante radius, mv by qb into omega. Ide kada? Yes. So, sir, you can simply see omega is equals to V into qb divided by mv. Ante Vv gone, it is equals to qb by m. So this is the angular speed. Omega, angular speed is qb by m. Your time period is given as 2 pi m by qb. Your radius is given as mv by qb. So these are the very important results to remember. Good pet kondi. It's not 3 pi r. What are you talking? It should be 2 pi r. Okay? Yes. So this is the radius. This is the time period. This is the angular speed. Andariki chuskondi okasari. And everything I can control it from my hands only. Okay? Yes, that is the beauty of physics. Very good. So this is my angular speed omega ra. What else do you remember, sir? Do you remember something else, ra? Do you remember something else, sir? Time is equals to 2 pi by omega. You remember something like this? 2 pi by omega. theta by omega, total time, total displacement 2 pi circular motion లో divided by omega అంటే 2 pi divided by omega value substitute చేసుకోండి ఒక్కసారి qb by m అంటే you reverse it, time is equals to 2 pi m by qb, same value వస్తుంది చూసుకోండి, same value. Go with whatever you want, your answer will be the same. Okay, చెప్పండి అందరికి, do you have any doubts in it? I don't. Yes. So now let us take a question based on this andariki. If possible, I will try to find a PYQ for all. Let us solve from a PYQ. I don't know if this topic has a PYQ or not, but చూద్దాం. చెప్పండి. Simple formula kada. Yes. You understand one thing in this question. One thing ante entira, this b bar whatever it's there, ee b bar lo I cap and j cap చూసుకో, bi bj అంటే same values bb అదే కదా, only k bar is varying అంటే b not k cap. So that means your first and second terminology should be same అంటే I bar and j bar term should be same. Try to tell me, any one of you, if you can tell me. ఓకే చూద్దాం. Just zoom it out a little if possible. Good. చూసుకోండి అందరికి చెప్పండి. So what you can say here is F is equals to Q into V bar cross B bar. ఇదే కదా? Yes. కానీ there is a condition. What is the condition, Ray? Yes. What is the condition, Ray? చూసుకో. Q value ఇచ్చారు కదా? Q value is 1. Substitute 1 అంటే your force F bar is simply equals to 1 into V bar cross B bar. No matter into it. ఇదే కదా? కానీ the twist is this V bar it is given in IJK form. Similarly for B bar it is also given in IJK form. Other. So sir, you can simply say your F bar value it is also given. చూసుకోండి. F is 4i minus 20j plus 12k. Sir 4i minus 20j plus 12k ఇదే నా ఫోర్స్. ఇదే కదా? It should be equals to V bar. V bar value కూడా ఇచ్చారు. చూసుకోండి. V bar అంటే 2i 4j 6k. అంటే it should be equals to 2i plus 4j plus 6k cross. It is a cross product. చూసుకోండి. F is equals to Q into V bar cross B bar. ఇదే కదా? V bar cross B bar. B bar value లో it is Bi plus Bj plus B naught K. అదే అంతే కదా? ఎస్. సో నౌ యూ హ్యావ్ టు డూ ద క్రాస్ ప్రొడక్ట్. క్రాస్ ప్రొడక్ట్ అంటే ఎలా చేయాలిరా? ఐజేకే దాని తర్వాత టేక్ ద నంబర్స్ 2 4 6 కదా? ఎస్. సో ఇట్ ఈస్ 2, ఇట్ ఈస్ 4, ఇట్ ఈస్ 6. ఎక్కడి నుంచి బి నాట్ రా. సో హియర్ ఇట్ ఈస్ బి, here it is B, here it is B naught. So answer ante idi total cross product. This should be equals to your original answer 4i minus 20j plus 12k. Ide 4i minus 20j plus 12k. Chuskondi exam hall lo you do not have this much of time ra. So your calculation, your rough work must be very fast andariki. Ide kada? Yes. So 4i minus 20j plus 12k directly చేస్తున్నారు. చూసుకోండి అందరికి. సో I into in bracket it is 4b naught minus 6b. ఇదే కదా? yes. so 4b naught minus 6b minus j into చెప్పండి minus j into 2b naught minus 6b 2b naught minus 6b. actually I don't need much of it. నా దగ్గర రెండు ఈక్వేషన్స్ ఉంటే I can directly equate it. చూసుకోండి. here it is I bar, here it is I bar, here it is 4b naught minus 6b and here it is 4. అంటే నా ఫస్ట్ ఈక్వేషన్ వచ్చిందిరా. సో ఇట్ ఈస్ 4b naught minus 6b it is equals to 4. ఇదే నా ఈక్వేషన్ నెంబర్ 1. దాని తర్వాత you can simply say minus j come out 2b naught minus 6b is equals to 20. అంటే 2b naught minus 6b should be equals to 20. అదే సబ్ట్రాక్ట్ చేసుకోండిరా. when you subtract you are left with 2b naught should be equals to 4 minus 20. 4 minus 20 is minus 16, sir. And you can simply say B naught is equals to minus 16 by 2 ante minus 8. B naught ki value minus 8 ante option C and D are gone. Ide kada? Yes. Now you lift this value and substitute in any one of the original equations. So idi equation చూసుకోండి. ఈ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేసుకోండి. B naught value minus 8 అంటే 2 into B naught value అంటే minus 8 minus 6 into b is equals to 20. ఇదే కదా? 2 into minus 8 is minus 16 minus 6 into b is equals to 20. ఇక్కడ నుంచి minus 6 into b is equals to 36 and b is also equals to minus 36 divided by 6 అంటే minus 6. b value కూడా minus 6 వస్తుంది. Is it correct or am I doing any mistake? చెప్పండి అందరికి. Very good, very good. When you lift and substitute it, you are getting minus 16 plus 16 minus 6b is there. It should become minus 6 and minus 6i minus 6j minus 8k should be the answer for this. Okay? Yes. Sorry. Now, let us move further. Ante endira? Ante option B. it's not option B, sir. It's option A. Andariki చూసుకోండి ఒకసారి. It should be option A, okay? It should be option A. No, no, no. You're dividing it. You're not multiplying. See, when you have minus 6b is equals to 36, ఇదే minus 6 multiplication tool ఉంటుంది. You send it over there. It does not become plus 6. చూసుకో. When it is minus 6b is equals to 36, you have two different ways to go. Your first way is minus 6b becomes plus 6b and here remains 0. So 0 is equals to 36 plus 6b. Then our first option. And if you want to find the value of b, minus 6 is in multiplication. You send there, it goes in division. Kani, still it becomes minus 6 only. So b is equals to 36 divided by minus 6. So these are the two options that you go with. We want the value of b, gada. So why would we go like this? We just say 36 by minus 6 and minus 6 is the answer for this. Okay. Yes, great, good. Choose Kondi. Now let us do some experiments. Aim experiment cheyali. Sir, let us imagine I have a magnetic field, something like this. Andariki chala important experiments. Choose Kondi. So this is my magnetic field. Okay, yes. Line చూసుకోండి, right? It's a perfectly space for a magnetic field. Okay, yes, yes, yes. Okay. So now what I'm doing is, ఇప్పుడు I'm taking a charge q. అందరికి చూసుకోండి. So this is my charge q. It is actually outside of the magnetic field for now. So ఇప్పుడు ఏం చేయాలంటే you throw it. Okay, you throw it. ఎలా throw చేయాలి sir? You throw it exactly perpendicular to the line. అంటే your speed v should be something like this. So you are throwing it in a very special way, అంటే very symmetric way. Symmetric way అంటే తెలుసా? అంటే you are throwing it in a perpendicular way. ఏమైతుంది సార్? It will complete a circular motion and it will exit back in the same way. Not like this. It will also exit back in the same way with the same speed v. అంటే తెలుసా? Your radius, the center of the circle and the velocity. What I'm telling? చూసుకోండి అందరికి. Your radius, your center of the circle and your speeds. చూసుకో. Where is the center of the circle? Where is the center of the circle? Center ఎక్కడ ఉందో చెప్పండి అందరికి. Where is the center of the circle? What are you telling, sir? Center of the circle. How to make the distance? చెప్పండి. Sir, in scenario low, this is a very standard scenario. Let us take one more case. Kani, akkada we will not be doing the symmetric experiments. చూసుకోండి. ఇదే నా second case and ఇదే నా third case. Now second case low, the same magnetic field is there. Okay. So it is the line, ante same line, same. Here also, this is a magnetic field. I want to tell you the difference. Okay, what is the difference? Same difference untundi. Cheppandi andariki. What is the difference and what change it will cause, This charge was q. Idu ekkada kuda the charge is q itself. So this is my charge q, and here also the charge is q itself. So ide na charge q. The only change that I am doing is, in first case lo, I was throwing it in a very perfect way, ante exactly horizontal, perpendicular to the line. Kani ekkada vachi, I am not throwing it in a perfect way. I am throwing it something like this. Chuskondi, ide na speed v, and in this case I am throwing it something like this. This is my speed v. Emaitadira? The center will change. The center will change. Ante enti sir? When you throw it something like this, the charge will go on and perform and come like this. Chuskondi. This is the example. Okay, and here when you throw it like this, it will go something like this and come out something like this. Are you understanding everything? Are you understanding something or not understanding? Okay. సెంటర్స్ గురించి మాట్లాడితే ద సెంటర్ ఆఫ్ దిస్ సర్కిల్ ఈ సెమీ సర్కిల్ కదా, ఇది సెమీ సర్కిల్ ఉంటే ది సెంటర్ విల్ బి ఎగ్జాక్ట్లీ ఆన్ ద లైన్. సో దిస్ ఈస్ ద సెంటర్ ఆఫ్ ద సర్కిల్. అదే ఎక్కడ వచ్చి ద సెంటర్ ఆఫ్ ద సర్కిల్ విల్ బి సమ్వేర్ ఇన్సైడ్ రా. సో దిస్ ఈస్ ద సెంటర్ ఆఫ్ ద సర్కిల్ అండ్ హియర్ ద సెంటర్ ఆఫ్ ద సర్కిల్ విల్ సమ్వేర్ బి అవుట్ సైడ్ ఆఫ్ ద మ్యాగ్నెటిక్ ఫీల్డ్. అదే those are the differences. Okay, that is the difference. అందరికి చూసుకోండి. So when you talk about the radius, this is my radius ante kada. Yes, this is my radius ra. And ekkada kuda this is my radius andariki chuskondi. This is my radius. Ela calculate cheyali sir? How am I telling the radius? You join the two ends. Two ends ekkada join cheyali sir? On the line. What lines are on the intersection of these two lines? Ade. So this is the intersection. Join it. This is the intersection. Join it. This is the intersection. Join it. This is your radius. Radius. Radius value same ra. mv by qb. Gurtunda. This is the radius ante mv by qb. Ekkada kuda the radius remains the same. And this will also be equals to mv by qb. And the radius also remains the same. R is equals to mv by qb. What will be different, sir? What is the change? What is the difference? Difference ante the times will be different. What times ra? The time for which the charge was inside the magnetic field. And telusa here the charge is remaining for a decent time. For example, చూసుకోండి 4 second time. ఎక్కడ వచ్చి the charge will not be there for 4 seconds. It might say 1 second. ఒక second లో it will go and come out. Here the charge is spending more time కదా. So you can simply say approximately 7 seconds. Okay? Just remember, times are different. I don't want to continue. I don't want to write the expression for the time. Expression రావాలంటే you can simply say, sir, time is equals to theta divided by omega. ఇదే కదా. theta అంటే ఏంటిరా? theta అంటే ఈ కేసులో చూసుకోండి, theta is 180 degrees. 180 degrees. Yes. So theta is pi divided by omega. Omega value ఏంటిరా? What is omega, sir? m by qb. Hey. R is equals to mv by qb kada. Yeah, omega value ra. You will calculated everything. Omega is qb by m. Chuskondi. Your omega should be equals to qb by m. Ante m into pi divided by q into b. This is the time for which the charge is remaining into the magnetic field. Similarly, I want you to calculate for this and for this also. I'm not going to go into the much technical detailities of the question. We will just directly go and jump. Right. So no, not mandatory. You don't have to remember the times. Just remember that the times will be different for different scenarios. Okay? If you're not, it's not mandatory for you. If it's a JE person, then you could have said that it's mandatory for you, but not there. Okay? Chuskondi. Biot Savart Law. Okay? Biot Savart Law. Let us jump to Biot Savart Law. Andariki chuskondi. Biot Savart Law ante oka wire lo current I is flowing. This current automatically creates a magnetic field. Ante kada. This is what we have discussed. Chuskondi. And if this current is I flowing into the wire, the magnetic field will be produced something like this. Ide kada. Yes, chuskondi. Something like this. Ante your magnetic field will be something like this. Going in, coming out. So this is your magnetic field. This is your magnetic field. Ade kada. No problem, sir. Understanding till this point. No problem at all. Everything is good. Everything is so far so good. Till this point, right? Current is what, right? Current is flow of charge. Yeah. Current is flow of charge. Ante a current creates a magnetic field. Ante flow of charge creates magnetic field. Ante a moving charge creates a magnetic field. Ade understanding. That means A moving charge also creates a magnetic field. Oh my goodness. So that means if I have an object and a ball తీసుకోండి. Okay, ball, let us say mass m is there, and a ball ki I'm giving some charge q mass m charge q. Sir, it is at rest. Rest lo unte there is no problem. Kani okasari this charge starts moving moving with some speed v. Moving charge ante current unte it will create a magnetic field. So that means the result is that a moving charge, chala important, andariki chuskondi ra, okay? A moving charge creates a magnetic field. Ide kada? Are you understanding? A moving charge creates a magnetic field. Sir, how can you say it? Wire lo current is flowing and charge is flowing ra. Current is what? Current is equals to charge upon time. Ide kada? Yes, current is charge upon time. Simple expression ra. Simple expression. Okay. Yes. So current flowing and charge flowing. So if a current creates a magnetic field and charge is flowing into the wire, and that charge is creating a magnetic field. Why do I have to take the wire ra? I can directly make a charge flow ante I can directly make a charge move with a speed v. So it should also create a magnetic field. Ante kada? Yes. What is the value of magnetic field? Sir, let us go to the same mother problem ra. Ante Biot-Savart law. What does it say? It says Biot-Savart law. Chudani andariki Biot-Savart law. Biot-Savart law simply says small magnetic field. This chinna magnetic field d bar is equals to mu naught I into dl bar cross r bar divided by 4 pi r cube. Okay. So, sir, anyhow, your current and your time are related. Ante kada? Yes. It has a different proof. But to save the time, I am giving you this proof. Okay? But to save the time, I am giving you this proof. Choose kondi andariki. Sir, this current can be written as charge upon time. Ante your small magnetic field dB bar could be written as mu naught into ee current ki place lo substitute charge upon time. Ide kada? Yes. Into dl bar cross r bar divided by 4 pi r cube. Ardhamandi? Yes. No problem till this point. No problem. Andariki chuskondi. Ippudu when you substitute this, you try to merge ra. Try merging these two expressions. Chuskondi. dl by t ra. dl ante enti ra? Ee wire lo dl ante the displacement that the charge has covered. dl bar ante telusa? dl bar is the small displacement on the wire. Hey, try to remember. We used to take the same dl in your Biot-Savart law. Okay? Same displacement in your Biot-Savart law. Sir, displacement by time. If you assume current to be uniform, we are assuming the same thing. Displacement by time. Speed. Velocity. Yes. So, sir, it could be written as mu naught into q times of dl bar by t ante velocity v bar cross r bar divided by 4 pi r cube. This is the magnetic field dB bar. So this is your magnetic field dB bar. Chala important formulas. Andariki chuskondi. So far so good. Whatever we have discussed, we want to revise. So sir, revision lo, the topic that I started this class with, ante, if you have a charge, moving charge, you try to imagine this. I'm trying to merge both the situations. So it is the time to be mature. Andariki. If you have been listening to this lecture from the beginning, it is a time to mature. Mature ante club everything that we have learnt. అంటే ఏంటిరా అంటే మీ దగ్గర ఒక మ్యాగ్నెటిక్ ఫీల్డ్ ఉంటే చూసుకోండి అందరికి. సో ఇఫ్ యూ హ్యావ్ అ మ్యాగ్నెటిక్ ఫీల్డ్ V bar that is going into the plane. ఈ మ్యాగ్నెటిక్ ఫీల్డ్ యు ఆర్ ప్లేసింగ్ అ చార్జ్, నాట్ ప్లేసింగ్, యు ఆర్ మూవింగ్ అ చార్జ్. అంటే మీ దగ్గర ఒక చార్జ్ Q ఉంటే యు ఆర్ మూవింగ్ విత్ సమ్ స్పీడ్ V. అదే కదా, moving force is getting exerted. Due to that force, the charge is performing a circular motion. So point number 1, చూసుకోండి, when a charge moves in a magnetic field, అదే కదా, when a charge moves in a magnetic field, చెప్పండి ఏమైతుందిరా? What will happen? What will happen when a charge moves in a magnetic field? When a charge moves in a magnetic field, it experiences a force. ఇదే కదా? Yes. What is the value of that force? It experiences a force. Force ante sir F is equals to Q into in bracket V bar cross B bar. I know till this point. Ade. But at the same time, moving charge kada, sir, it is moving in a magnetic field and it's a moving charge. Moving charge unte, what did we discuss? A moving charge creates magnetic field by itself. Ante, sir, this charge is moving. Ade kada, this charge is moving. That means it is creating the magnetic field also, ra. Too much confusion, sir. Too much confusion. What is happening, sir? Sir, moving charge in a magnetic field, force experienced. But at the same time, you are saying that this charge is also creating a magnetic field. B bar is also magnetic field and charge also creates a magnetic field. Formula cheppura. The second thing is a moving charge creates a magnetic field. Ade kada? Yes. Sir, a moving charge creates a magnetic field. Cheppandi, small magnetic field dB bar is equals to mu naught into Q times of V bar cross R bar divided by 4 pi R cube. So this is a magnetic field created by the charge. So sir, if I have an external charge, chusko, I'm trying to give you some experiments. Okay, I'm trying to ask you a question. Chuskondi andariki. So if I have a charge Q, if I hit it with some speed V, what will happen? It will create a magnetic field. Ade kada? Yes, it must create a magnetic field. Andariki chuskondi. It must create a magnetic field. Ante let us say V. Formula. I want to talk about magnetic field at this point. Hey, not this point. Let us say I want to talk about magnetic field at this point, dB bar. Cheppandi. R bar ante entira. This is my R bar. Ide kada? V bar cross R bar ante magnetic field is outside. చూసుకోండి అందరికి. I'm telling you a very important result. Okay, I'm telling you a very important result అందరికి. So if a moving charge is creating a magnetic field, don't you think that the same magnetic field will apply a force on this charge? So sir, charge created a magnetic field. Magnetic field applied force. If force valla, due to this force, the speed increased. Ante increased speed, increased magnetic field. Increased magnetic field, increased force, increased speed, magnetic field, force, speed, magnetic field, force, everything increasing. Until there should come a point at which the charge should have much speed. Until the speed should keep on increasing. What you're saying, sir? What you're saying, sir? So if the speed of the charge is increasing, until the energy is increasing, but you have given some energy, V, half mv square. You have given a small punch. So chinna energy. It started with a low energy, very low energy, but with the time the energy is increasing. But we know energy can neither be created nor be destroyed. What the hell is happening here then? You are telling that moving charge creates a magnetic field, and a moving charge in a magnetic field experiences a force. So if force is experienced, speed should increase. Speed increase, uh, if your speed is increasing, your magnetic field also increase. If magnetic field is increasing, force should also increase. Force is increasing, sir, speed should increase. Speed increasing, magnetic field should increase. Magnetic field increasing, force should increase. Force increasing, ante sir speed should increase, and this should keep going on, ante there should come a time when this charge should have an infinite speed. Why is it not happening? Okay. So it is a question for your thought. Not an answer. I'm not only telling you the answer for this. చూసుకోండి అందరికి. I'll be back in 5 minutes అందరికి. Okay. Hi. చెప్పండి అందరికి. So now I've left you with a question. I asked you one question. Okay, nobody has answered it. Hi Alingam, hi. So ఇప్పుడు let us talk about some devices. Devices అంటే ఏంటి? The first device is your velocity selector. Second device is your cyclotron. Yes. So they are the two things that are left. First is your velocity selector, and then it is your cyclotron. But before that, I want you to understand a phenomena. Phenomena ante entira? You imagine you have a magnetic field. Magnetic field ante your uniform magnetic field B bar, right, is moving from left to right. So this is your magnetic field. Andariki చూసుకోండి. Okay. Yes. ఇప్పుడు let us try to throw a charged particle. Force on a charged particle. తెలుసా కదా? Force on a charged particle. అందరికి చూసుకోండి. Sir, force on a moving charge in a magnetic field is given as Q into V bar cross P bar. అంతే కదా? Yes. అంటే QVB sin theta. This is your force రా, చూసుకోండి. మళ్ళీ ఒక్కసారి I'm again telling you again and again. In this case, this is my charged particle. Let us say charge is Q ra. Kani instead of throwing it straight, I am throwing it with some angle ra. చూసుకోండి. This is my speed. Angle is theta. Andariki. So this is the way I am throwing this charged particle. ఏమైతది అందరికి చెప్పండి ఒకసారి. So sir, if you are throwing it like that, it will get resolved into components kada? Yes. So this will be the first component of the speed and idena second component of the speed. Ante kada? Values cheppandi okasari. Values gurinchi cheppalante this speed will be v into cos theta and ekkada vachi this speed becomes v into sin theta. Ade kada? Yes. Okay. There is a problem. What problem? Problem is this theta is the angle between V bar and V bar. Ide kada? Hey, చూసుకోరా. V bar is the angle between V bar and V bar. V bar ante entira? Simply the speed of the charge. Speed of the charged particle. Ide kada? Yes. So your V bar is the speed of the charged particle. కానీ ఈ సినారియోలో రెండు స్పీడ్స్ ఉన్నాయిరా. The first speed is V cos theta. Magnetic field is also towards the right. V cos theta is also towards the right. అంటే both the vectors are parallel. Parallel vectors ఉంటే the angle between the vectors will automatically become 0 degree. ఇదే కదా? Yes. So the angle between the vectors is 0. అంటే ఈ కేసులో the value of theta is 0 degrees. Hey, not this theta ra. Hey, చూసుకోండి రా. This theta is different, that theta is different. అంతే కదా? So let us say instead of this theta, I'm writing some another angle ra. So చూసుకోండి. Let us say this angle is alpha. Okay. So this angle is alpha అందరికి. ఈ alpha ఉంటే you can simply say, sir, here it will be V cos alpha and V sin alpha. Ade kada? Yes. So these are the Alingam, we will do it. Don't worry. This syllabus complete aina tarvata, my only goal will be to solve all 40 years PYQ or whatever it is there. Okay? At least 15 years PYQ, we will solve it. Every chapter we will take it from 2025 నుంచి at least 2010 వరకు. We will solve all the question papers. Don't worry about that. But before that, let us first cover the syllabus అందరికి. So ఇక్కడ చూడండి రా, V cos alpha is towards the right side. V sin alpha is vertically upwards. అదే కదా? V cos alpha right side లో ఉంటే V bar కూడా right side లో ఉంటే angle between them is 0. చూసుకో. First case లో v cos alpha towards the right, b bar kuda towards the right. Ante theta is equals to 0. Ante force cheppandi ra okasari q into v into b into sin theta ade kada. Yes, so that means sin theta 0, sin 0 0, ante net force is 0. That means this speed of the particle, it will not change endukante force is 0 ra. Ante this particle will keep on going in a straight path. Are you understanding? Very good. Kani, if you see the second aspect ante enti ra, second aspect lo your b bar direction is towards the right only, చూసుకోండి. కానీ your second speed v sin alpha is in the upward direction. Oh my goodness. So this is your v sin alpha. దీంట్లో angle is 90 degrees ఇదే కదా. Yes, so దీంట్లో angle 90 degrees అంటే force F is equals to q into v into b into sin theta అంటే sin 90 ఇదే కదా. Sin 90 is 1 అంటే q into v speed. What is the speed ra? Speed is v sin alpha multiplied by b. So this is the force. Direction sir, v bar cross b bar kada. So v bar upward ra, v bar is upward, b bar is towards the right, v bar cross b bar is inside. Ante this particle will go something like this. చూసుకోండి, first speed v cos alpha is there, it is moving to the right side because of this v cos alpha. But at the same time, this v sin alpha is there and magnetic field is towards the right side. Force cheppandi inside kada. Yes, so the particle is going to the right and moving something like this. Are you trying to understand? Here it is going forward also, moving also. Ante the path will be helical path, something like this. Try to visualize it. Ante the net path of the particle looks something like this. Can you understand? Ante this, it is going in, coming out, going in, coming out, going in, coming out. And at the same time, it is also moving towards the right side. It is also moving towards the right side. Ante kada? Yes. So, can you tell me where is the circular motion getting completed? Ante enti ra చూసుకోండి. It's a very difficult path actually. ఎందుకంటే there are two different motions happening in the same scenario. Sir, particle is moving something like this. Okay, something like this. But at the same time, it is going forward also ra. So the situation will look something like this. Particle moving at the same time, going forward ra, something like this. So this is the helical path. Understanding? Okay. Yes. So you started from this point and to come back at the same point. You started at this point and to come back at the same point. Same point ante telusa. Started somewhere here. Moving and coming somewhere here. Same point. Started here, moving and coming at the similar position. Here. Choose. This distance whatever you have traveled, starting from the same point and coming from here, this distance whatever you have traveled is known as the pitch. This distance is known as pitch. Ante kada? Yes. Okay. Previous year kuda, year kuda, this year the paper has not happened. Okay, who is this? I think he has deleted the message. Okay. Alright, idiot. This paper for this year has happened, ra. This is January, right? Hey, in January you are expecting NEET, huh? 2025 is. Okay, చూసుకోండి అందరికి. Pitch అంటే ఏంటి? In one pitch, you try to understand it. Okay, in one pitch, the particle is completing one circular motion. ఇదే కదా? ఒక pitch లో the particle started from the topmost point, reaching bottommost point, and then coming back at the topmost point again. అంటే it has traveled this much of distance. చూసుకోండి అందరికి. ఇదే కదా? అంటే వన్ కంప్లీట్ సర్క్యులర్ మోషన్ అయింది ఇదే కదా ఎస్ సో ఒక సర్క్యులర్ మోషన్ కోసం టైం పీరియడ్ చెప్పండి ఒకసారి సరే టైం పీరియడ్ ఇస్ 2πm/qb 2πm/qb గుర్తుందా టైం పీరియడ్ ఫర్ సర్క్యులర్ మోషన్ అదే సో సార్ టైం ఇస్ ఈక్వల్స్ టు 2πm divided by q into b so this is your time period ra it is independent of the speeds ante kada yes so this is your time period 2πm/qb what next ra what next sir naku distance kavalante distance is equals to speed into time ide kada yes so sir your pitch is equals to distance is equals to speed ante enti ra v cos alpha multiplied by time enti ra it is 2πm/qb ade so this is your pitch you want to remember leda leave it okay very good okay so this is something known as your helical path low pitch time period everything has been written over here itself okay dan tarvata let us talk about some devices ra device number 1 is your velocity selector what are you talking sir velocity selector ante enti ra from this device you do some experiments ante you remember in 1800s in 1920 there were some scientists doing some experiments ante alpha scattering experiment gurtunda alpha scattering experiment ante enti sir ee alpha scattering experiment lo you throw the helium nucleus ante charged particle from a velocity selector you can use the velocity selector is a tool what is the function ra function is number 1 it only selects charged particles having a particular speed and throws them ide kada yes what are you telling sir particular speeds and throws them ante enti ra hi everybody hi so here you understand the functioning of the velocity selector I will tell you everything చూసుకోండి velocity selector lo you have two different plates you can take plates also if you want you can take any other thing so ee plates ante I'm charging this plate with a positive charge andariki చూసుకోండి చాలా important discussion okay it's a very important discussion all of you understand it is a positively charged plate ee plate pai I'm giving it a complete positive charge similarly on this plate is a negatively charged sir positive negative are you understanding is it visible andariki is it visible whatever I'm writing to you right hey, it's a positive charge okay it's a positive charge positive charge okay positive charge and this is a negative charge plate okay positive negative charges unte emaitadi sir there will be electric field now you are taking us to electrostatics chapter too much headache sir too much headache yes you have to go to electrostatics ra you have to go to electrostatics ante the field line ante positive field line negative field line the field lines will be something directed from positive charge to negative charge gurtunda origination of electric field lines start from a positive charge and end at a negative charge so this is your field line ra chuskondi yes very good sir understanding something we are understanding sir this is the direction of your field lines other so these are your field lines ante kada what will happen with the field line ra okasari you are telling that you have a field ante the charge is now going to experience a force in that field ade kada yes ఒకసారి మీ దగ్గర ఫీల్డ్ ఉంటే the charge will definitely experience a force. చెప్పండి, what is the relationship రా? The relationship between field and force, F is equals to Q into E. ఇదే కదా, F bar is equals to Q into E. What about direction of force, sir? The direction of force is always in the direction of electric field. అంటే ఫీల్డ్ పైన నుంచి కిందకి యాక్ట్ చేస్తున్నారు కదా, the force will also be acting in the same direction. The force will also be acting in the same direction ante if I am placing any charged particle Q ra చూసుకోండి అందరికి, if you placing any charged particle Q, it is going to get a force in the downward direction because of these two plates. ante kada, because of the two charged plates ra field untundi, field it will create a force in the direction of itself. ade kada, yes. So sir, ఈ సిచ్యువేషన్ లో ఇఫ్ ఐ am throwing any charge into this scenario, చూసుకోండి అందరికి, if you are throwing any charged particle, అందరికి it's a very important thing రా, if you are throwing any charged particle with some speed v రా, any charged particle with some speed v, ఏమైతుంది, only electric field is there కాబట్టి it will experience a force in the downward direction. అంటే after some time the force will hit and the charge will stick to the plate. అంతే. This is something going to happen for now ra, for now అర్థమైంది అందరికి, yes. కానీ we are not fools ra, అంటే we are smart people, not we, I అంటే scientists and me also, not you, you are waste fellows ra. I am a smart person. So what I am doing now is at the same time I am also turning on the magnetic field. Magnetic field, yes, magnetic field. చూసుకోండి, magnetic field will be something like this. You will turn on the magnetic field and the direction of the magnetic field will be into the plane of the paper, something like this. అందరికి చూసుకోండి, if you are understanding this or not understanding చెప్పండి ఒకసారి. So this is the magnetic field and this is the electric field. They are existing at the same time, okay, they are existing at the same time. So what will happen, sir? Due to electric field, చూసుకోండి, due to electric field the force will be in the downward direction. Due to electric field, ఎందుకు sir? Because electric field is in the downward direction కాబట్టి force is also in the downward direction. Point number 1 వచ్చేది. What about magnetic field ra? Magnetic field also creates a force. What is the force, sir? Sir, F bar is equals to Q into V bar cross B bar. Gurtunda? V bar cross B bar. Hey, now let us try to talk about magnetic force. V bar in the right, B bar into the plane. Sir, V bar cross B bar. V bar to the right, B bar into the plane, V bar cross B bar ante paina ki act. So that means on this charge, magnetic force is in the upward direction and electric force is in the downward direction. Ante kada? Yes. So in scenario lo, your magnetic force is acting in the upward direction and your electric force is acting in the downward direction. Ante kada? Yes. Hey, చూసుకోండి. What next, sir? ఇప్పుడు there is a condition. What is the condition, ra? Magnetic force చూసుకోండి, Q into V bar cross B bar. Understand. Your condition is F is equals to Q into V bar cross B bar. So this is my charged particle, ra. You visualize this charged particle situation. There is an electric force Q into E on this charge in the downward direction. At the same time, painaki it is experiencing a magnetic force. Enta sir? Q into V into B. Ide kada? Yes. So if the two forces should be equal, if the two forces are equal, ekkada kuda there are two more things happening, ra. Two more things happening. Rendu events, they are happening at the same time. The first scenario, if your magnetic force is equals to electric force ante QVB, it is equals to Q into E. Ide kada? So paina ki force, kinda ki force, they are equal ante this charge particle will not move up and down, balanced forces, and it will go straight and it will come out of it. What speed, sir? Speed should be equals to, చూసుకోండి, speed q gone kada, so v is equals to e by b, అదే e by b. So if your speed is equals to e by b, that means this particle will not move up, it will also not move in the downward direction. E value kosam the particle will be coming exactly out of these plates. What will happen, sir, if the speed is less? Speed less and your magnetic force is less. Ide kada, your magnetic force FB ra. Speed less and magnetic force less. If your magnetic force is less, your electric force is more. Sir, electric force kindaki, magnetic force painaki force ante takwa, kindaki force ante ekwa. So automatically it will hit your lower part. When will it happen, ra? If V is less. Similarly, if V is more, magnetic force is more, so V is more and it will hit the upper plate. Chuskondi. If you have 100 charged particles, మీ దగ్గర 100 charged particles ఉంటే, you will give different speeds to different particles. అదే కదా? But all of them will not pass this setup ra. Only those particles will be crossing whose speed is equals to E by B. Other the name is velocity selector. It will only let pass the particles whose speed is E by B. If the speed is more, it will stick to the upper plate. If the speed is less, it will stick to the lower plate. So this is the working of your velocity selector. Now you tell me how many of you have understood this. Ante kada? Yes. So this is a condition that you must remember. Next, let us talk about cyclotron. If at all you have to understand cyclotron, you must be good with two concepts. What are the two concepts, sir? First concept is, oka charge ni oka electric field lo pette, it will experience a force. Ide kada? Yes. The first concept is, if you have two different plates, andarki chuskondi. I'm just telling you a setup of the experiment ra, chusko. E plate low, I'm giving it a complete positive charge, and on this plate I'm giving it a complete negative charge. Ide kada? Emaitadira? Kasari charges vaste, there will be a electric field. Okay, there will be an electric field. Direction cheppandi okasari. What is the direction of this electric field? The direction of the electric field starts from positive charge and ends at negative charge. Ide kada? Yes. So this is your electric field E bar andariki. అర్థమైంది కదా? Good. Very good. Now, when you are placing a charged particle at one end of this plate, until let us say charge is Q, I want all of you to understand this. Okay, I want all of you to understand this. Choose. Yeah, Maitri, the class will be 1 hour more. Okay, 8:20. We will take it till 8:20 or 8:25. 8:20. Mostly by 8:20. Okay. Let us end it by 8:15. Mostly by 8:15. So that we will get 20 minutes extra time, right? Yes. It will be completed by 8:15. I also don't have other parts. I only have to talk about your cyclotron, then tarvata your magnetic moment, torque on current carrying loop also is there. Okay, so let's talk about torque also. Cyclotron, force on a current carrying conductor, magnetic moment, torque. 4 things are remaining. Okay, and then your chapter will be completed. Choose code. So when your charge is Q, choose code. Let us say distance is D, electric field is E. Andariki. What is the formula for potential? Potential is equals to, చెప్పండి అందరికి, what is the formula for potential? Sir, potential is equals to integral E dx. Constant field unde, you can simply say, sir, potential is equals to E into D. D is the distance between the plates. Andariki చూసుకోండి. Sir, this is the potential difference between the two plates. ఇదే కదా? Yes, this is the difference between, potential difference between the two plates. When you are releasing this charge from this side, చెప్పండి, what will happen, sir? This charge will experience a force. F is equals to Q into E. In the right side, ఇదే కదా? This is your force. ఇదే మీ force రా. If you have force, force will give you acceleration. F is equals to ma, A is equals to F by. Okay. If you have acceleration, your speed will increase. V is equals to U plus AT. ఇదే కదా? U value 0 ఉంటుంది. Your V should be equals to A into time. As the time is increasing, your speed is increasing, and your kinetic energy is increasing. ఇదే కదా? Yes. So as soon as you are releasing this charge particle, the electric field valla, it is getting accelerated. It is getting force, speed, change in kinetic energy. చూసుకోండి. Whatever change in energy this particle is having can also be given as Q into V. V ante voltage ra, not speed. Ippudu చూసుకోండి. V is the potential difference. It is not speed, okay? Capital V ఉంటుంది ra. V is for voltage లేదా potential difference between the two plates. ఇదే కదా? Good. Good. So in one complete journey, చూసుకోరా, you are releasing it, it is coming to the negative plate. Energy increased. By what amount, sir? By the amount of QV. Okay, what I'm doing now is, it has the energy equals to QV. అదే కదా? Same energy, I'm lifting it and I'm again placing it at this point. చూసుకోండి అందరికి. ఎప్పుడు it has the energy equals to QV. చూసుకోండి. The energy is QV, I'm just lifting it, again releasing, again it will cover a journey. Then its energy increases by QV. మొదటిగా energy was 0. After one journey, energy became Q into V. దాని తర్వాత again I am lifting it, again it is moving, increasing by QV. Initially it has QV, increased by QV, and its new energy will become 2QV. అదే కదా? Yes. Again I am lifting it, I am releasing from this point. Initial was 2QV. After the journey, it becomes 3QV. Are you understanding? Are you understanding this? Until the energy is getting increased. But what is the problem, sir? Problem is, we always need the external person to lift and release. To lift and release. To lift and release. అదే కదా? You always need the external person. చాలా complicated scenario, sir. Let us do some smart arrangements. What are the smart arrangements, ra? ఒక్కసారి your charge has approached this point, ra. దాని తర్వాత the only thing is to change the direction. అదే కదా? Yes. To change the direction. Direction అంటే ఏంటి? You are lifting it, again you are releasing it, something like this. అంటే you only have to change the position. ఎలా చేంజ్ చేయాలి, sir? Do we have some tool? Do we have some tool? Yes, we have. What is the tool? Magnetic force. How do you use it? ఒకసారి you have the speed, charge performs circular motion, ra. Understanding ante if the charge particle by itself is coming at this position by rotation, it will be a very good thing. Sir, circular motion unte I want magnetic force QVB radius is equals to mv by QB ante kada. You remember that results ra. So sir, naku magnetic field kavali. How will I adjust that magnetic field? Okay sir, I am understanding something now. Chuskondi. ఈ పాయింట్ లో వచ్చిన తర్వాత the speed of the particle is towards the right side and it is equals to v. అంతే కదా. What will happen if I directly introduce a magnetic field something like this? చూసుకోండి అందరికి చెప్పండి. So sir, q v bar cross b bar అదే కదా. q v bar cross b bar, that means the magnetic field will just change the direction of this force. Are you understanding? చెప్పండి అందరికి. Are you understanding this scenario? Yes, I think you should understand this. Okay. Leda should go something like this. You're getting confused. Okay, very good. So that means if I'm introducing a magnetic field, the direction is getting changed and there is a possibility that this charge might come at this distance. Ade kada, it was in the right, you have changed the direction, now it is in the left. You can use the magnetic force to change the direction and you can use the electric force to increase the energy. Every journey energy increasing by QV. Ade kada. Yes sir, every journey energy increasing by QV. If we change the direction, it will again come back. Again QV, change the direction, again come back, again QV, 2QV, 3QV, 4QV, 5QV, 6, 7, 8, 9, 10 and you can keep on increasing the speeds of it. Are you understanding? This is how you throw the charged particles from a cyclotron. Are you understanding? The only function of cyclotron is to increase the speed of a charged particle. You cannot increase by your hands. That is the biggest benefit of your cyclotron. So ఇప్పుడు I am telling you the construction of cyclotron. చూసుకోండి అందరికి. So cyclotron construction లో you have two D's రా. D అంటే D for Delhi. D, you have two D's. D's అంటే చూసుకోండి. This is your first D and this is your second D. అంతే కదా. I hope it's visible. D అంటే చూసుకో. What we do now is we apply or we set your electric field between the two D's ra. We are basically setting your electric field between two D's and at the same time we are also setting your magnetic field. Ante this is your magnetic field. Sir, why this magnetic field, sir? This magnetic field is only useful to change the direction of the charged particle. Ikkada kuda the same magnetic field. You can imagine this D and it's something like this. I don't know how to draw it. Okay. So the charged particle can enter through this. So it's something like here also it is something like this. So that these are the empty spaces. I hope you are understanding what I want to try to say here. So this is actually the structure. And there is the open space, empty space, hollow space into these. You can insert your finger and you can move it up and down. Okay, it's an empty space here also, here also. So between the two D's there is the electric field. Okay, between the two D's electric field is there. So sir, let us say I am releasing a charged particle Q. Let us change the ink now. Chuskondi. Your electric field is something like this between the two D's ra. Ide kada. Yes. So this idi me electric field E bar ra. So what is the function of this electric field? Only to increase the energy of the particle. Ante electric field nunchi force vastundi, force nunchi acceleration, then nunchi speed. If the speed is increasing, energy is increasing. Let us say the potential difference is V. V is the potential difference. Potential difference, okay? V is the potential difference. Capital V తీసుకుంటాను. V is the potential difference between the two D's. అంతే కదా. ఇప్పుడు I'm starting with a charged particle. చూసుకోండి. If I have a small charged particle Q, what will happen, sir? It will move something like this. అంతే కదా. It will move something like this. దాని తర్వాత what will happen? చెప్పండి అందరికి. So as it is reaching the other plate, the energy is increasing. How much, sir? Energy is Q into V. ఇదే కదా. V is potential. చూసుకోండి. V is the potential. Now it has gained some speed. Some speed, and let us say the speed is V dash dash, or లేదా you will just say U is the speed. U is the speed. Okay. Now as soon as it enters this D, here is the magnetic field B bar. చూసుకోండి. What will it do? It will apply a magnetic force. దాని తర్వాత it will move in a circle. So sir, after some time the particle moves something like this, come back again, మళ్ళీ ఒకసారి the radius increases, speed increases, radius increases, speed increases, radius increases, speed increases, radius increases, speed increases. Other. Hope it is understandable. Okay? So at each and every point of the time, your radius is keeping increasing. Ante kada? Yes. And also your energy is also increasing. Chuskondi. When it moved for the first distance, your energy was QV. When it moved for the second distance, chuskondi. When it moved for the second distance, your energy is 2QV. When it moved for the third time, your energy is 3QV, and it keeps on going. 3QV, 4QV, 5QV, so on and so forth. Okay. You're saying something, Andariki. You're saying something. Okay. Yes. If you want to talk about the kinetic energies, you can talk about the kinetic energies also. Cheppandi. Radius R is equals to mv by qb kada. V is for speed. V is for speed. Chuskondi andariki. Sir, energy for the first rotation is equals to q into v. Idi gain in energy kada. Yes. Energy ante a formula kinetic energy. So you can simply say, sir, half mv square should be equals to q into v. Ekkadi nunchi you can simply say, sir, mv square is equals to 2qv. M tone multiply cheskondi both the sides. So you can simply say, sir, m square v square is equals to 2qmv. Ekkadi nunchi you can simply say mv is equals to root of 2qmv is for potential difference, voltage, not speed. You lift the value, substitute cheskondi. Radius is equals to root of 2qmv divided by qb. So this is your first radius R1. దాని తర్వాత second radius is double the voltage. Third radius is triple the voltage. You can go on. You can keep on going in that scenario. Next, ఇప్పుడు we are concerned about force on a conductor placed in a magnetic field. చూసుకోండి అందరికి. So I'm talking about force on a conductor placed చెప్పండి. Not just conductor. If you only have the conductor, it will not experience any force. Okay. If you only have a conductor, it will not experience any force. Kabatti, you need current in the conductor. Ante the charge must be flowing through the conductor. Ante. Understanding? Yes. So imagine I have a magnetic field B bar, something like this. So ide na magnetic field ra. Okay? So this is my magnetic field B bar. Ee magnetic field lo I am placing a conductor. Ante let us say the conductor is having current I. Length of the conductor, sir, ekkad nunchi ekkad varaku the length is L. Ide kada? So what will happen? This conductor itself will experience a force. Will I experience it? How it will experience it? What do we know till this point? Cheppandi andariki. Force on a moving charge kada. What is the formula for force on a moving charge ra? Chuskondi. Sir, F is equals to Q into in bracket V bar cross B bar. Ide kada? What can we write about your charge? Charge. Again, I am telling you a very simple way. Okay? Again, I am telling you a very simple way. Chuskondi. Sir, Q is equals to current into time. Ide kada? Yes. So if an electron or if a charge particle started from here moving till this upper point, charge particle kada, protons, your positive charge, current I started from the lower end of the rod and going till the upper end of the rod. Ante cheppandi total displacement entara L, total time entara T is the total time. Substitute cheskondi sir. F is equals to, instead of this Q you substitute I into T times of V bar cross B bar. Ide kada? Yes. So sir, I into, you merge these two ra. Ee rendutni merge cheskondi. So you can simply say sir, I into V bar into T. V bar is the speed of the charge particle. T is the time. Sir, speed into time. Speed into time. Speed into time is displacement. Displacement. And L bar cross B bar. Ide kada? Yes. So this is your force on a current carrying conductor. I into L bar cross B bar. Chusko. Chala important. Okay? Very important result. This is your force on a current carrying conductor. L bar ante enti ra? L bar ante enti? L bar is the length of the conductor. Sir, L bar is length of conductor. Ide kada? L bar is the length of the conductor. Kaad. Wrong answer. Wrong. L bar is not the length of the conductor. L bar is the shortest distance between ends of a conductor. I will tell. Don't worry. Okay, chapta. So you will simply say ends of a conductor. Other. Now you must also understand about the direction of the force. Chuskondi. In scenario lo your current is I, your length is L, your magnetic field is B. Formula cheppandi, I into L bar cross B bar kada. L bar cross B bar ki direction ekkada vastundi ra? Sir, L bar is in the upward direction, B bar into the plane, L bar cross B bar ante in the left side. So automatically this conductor will experience a force in the left side. F is equals to I into L into B. Endukante sir, angle between L bar and B bar is 90 degree. L bar cross B bar is equals to L into B into sin theta. Theta ki value 90 degrees. Kabatti you can simply say yes. Aipoindi. Kinematics 1D 2D has been completed. Yes. Good evening. So you can say, sir, L bar cross B bar perpendicular, theta 90 degree, kabatti sin 90 is 1. So you can simply say I into L into B is the force on this current carrying conductor. Hey, what did I say? I told you L bar ante shortest distance between ends of the conductor kada. Let us see now. Ippudu I am going to show you something. Chuskondi andariki. So this is my conductor now. Ippudu చూసుకోండి. This this, this, this. Are you understanding? So this is my conductor. Ante entira? Ante the current I is flowing something like this, something like this. So this is your current I. Ante kada. Now my question is, if this length is L, idi guda length L unte, this is also length L, this is also L, this is also L, a regular hexagon. Regular hexagon kada. Hey, all the lengths are same, right? No, they are different. Okay? Your weightage is not equals to JE wala weightage, ra. What are you telling, Ray? Am I taking too complicated topics? It's there in your syllabus, okay? Don't say like that. Yeah? Okay. Yes. Chuskondi. So, in case lo, your L bar and net displacement is the shortest distance between ends of a conductor. Ade. Ends of a conductor. Leda, you can also say your L net bar is equals to the addition vector sum of L1 bar plus L2 bar plus L3 bar and so on and so forth. Why am I writing all this, sir? Because to know the direction, ra. Direction. I have to understand the direction, kada. So, idi na L1 bar. This is my L2 bar, L3 bar, L4 bar, L5 bar. Cheppandi. L1 bar plus L2 bar. Triangle law, gurtunda. Triangle law of vector addition, ra. Triangle law of vector addition. Okay. Triangle law of vector addition. What does it say? Something like this. So, your resultant of these two lengths is something like this. What about this and this, ra? Resultant something like this. What about this and this, ray? Resultant something like this. Okay. What about this and this? Your resultant will be something like this. So, this is total L net bar. Direction is bottom to up. Okay. Bottom to up is the direction of L net bar and value is simply equals to L. Endukante regular hexagon untundi kada. Yes. So, your L net bar is equals to L bar. Kani the direction is bottom to up. You can simply say J cap. Eppudu cheppandi what is the force on this conductor, ra? Sir, F is equals to I into L bar cross B bar. Ide kada. L ante net distance, right? Distance into displacement. Shortest displacement. Shortcut. So you can simply say, sir, I into L bar value is L, B bar value is B, ante simply equals to I into L into B. Ade kada. Yes. What if I have a loop, sir? Loop unte emaitadi. What if I have a loop? If I have a loop, L bar is 0. 0 kada. Loop unte chuskondira. This is your magnetic field ante kada. Yes. This is your magnetic field. This is your loop. Ede kada? Yes, your current is like this. I. Ekkada kuda the current is I. Here also the current is I. Here also the current is I. Cheppandi. What is the force on this loop? What is the force on this loop? Sir, L bar shortest distance. Cheppandi. You start from one end and complete the shortest distance. Sir, I started at this point. Completed. Displacement is 0 and L bar is equals to 0 and force kuda 0 vastundi. Understand? Whenever you have a loop, current carrying loop placed in a magnetic field, the net force becomes 0. Okay? If annetni, you can also say something like this. Okka separate lengths teeskoni calculate cheskondi. Cheppandi andariki. Sir, length is L, length is L, length is L, length is L. B bar is into the plane kada. I L bar cross B bar. Cheppora. L bar towards the left. B bar into the plane. L bar cross B bar ante net force is in the downward. Kindaki act chestunnaru. Ade kada. So your net force is downwards I into L. Right? Tell me here, L bar cross B bar left side lo. Ante your F is equals to ILB acting in the left side. Ekkada vachi your L bar cross B bar paina ki act chestunnaru kada. So your your magnetic force F is equals to ILB acting in the upper direction. And here your force is towards the right side and F is equals to ILB. Choose all the four forces up, down, balance 0, left, right, balance 0, net force becomes 0. Your loop is at rest. Your loop is at rest. It will not move at all. Kani, you break it even a little. Okay, what will happen now? Now, sir, I got a little chill in my body, so I'm breaking it something like this. I'm just breaking it this much. Eప్పుడు this loop will experience a force. It's not a loop anymore, kada. It is an open end. Chuskondi. This is an open end, so it will experience a force. How much force, sir? I into L bar cross B bar. This is a force. L bar and a net length. Understanding? Understanding? Yes. So this is the force. But if you have a loop, net force is 0. Chuskondi. I'm writing with a star mark. Magnetic force in a current carrying on. It should be on. And remember one more thing, okay? Chala important thing. I'm talking about magnetic force. Force. Gurupetkondi. This is my magnetic force. I'm not claiming any other thing. I'm only talking about the magnetic force, okay? Magnetic force on a current carrying loop is always 0. Endukante the length L bar is 0. Displacement between initial and final point is 0. Leda, you can also say each and every side is getting balanced. So if this is my magnetic field and this is my loop, loop. What is the net force? Does not matter whatever current it is flowing into it. Loop ante closed figure. Okkasari closed figure you can directly say the force is 0. Force will 0. Force, not torque. Torque is a different quantity, force is a different quantity. So the force will become 0. Let us talk something about magnetic moment. Okay, let us talk something about magnetic moment. Yes, very good. Okay. Good. Okay. What is a magnetic moment? Chuskondira. A magnetic moment tells you the strength of the magnet. Yes. Let us see. This is a bar magnet. Bar magnet ante, let us say this is the north pole, this is the south pole. Yes. This is your bar magnet. Let us say the length of this bar magnet is 2L. So the length of your bar magnet is 2L. There is something known as pole strength. Pole strength. You defined it with a letter small m, okay? Small m ante entira? Small m ante pole strength. It is not in our hands. Pole strength depends on magnet to magnet. Strong magnet unte pole strength is strong. Weak magnet unte pole strength is low. Ade kada? Yes. So based on these terminologies, we defined a new terminology, m bar. Bar, sir. Bar ante vector, sir. Ante it also has directions, sir. Yes, it has directions as well. So ekkad nunchi you can simply say, sir, m bar is equals to m multiplied by 2d. Something like q into 2d ra. Electric dipole gurtunda. Similarly, we have magnetic moment. Leda magnetic dipole kuda rayochu. You can write whatever you want to write. Magnetic moment leda magnetic dipole moment leda magnetic dipole. Ade. Okay? Okay, magnetic dipole moment kuda same ra. M bar is equals to 2 into m into d or m into 2d. Ade kada? Yes. So let us talk about field lines ra. I've written at least 2-3 times before, but again, malli okasari rastunnaru chuskondi. Your magnetic field lines start from north pole, end at south pole. Ade kada? So these are your magnetic field lines. Something like this, right? Chuskondi. And they go on like this. Ante kada? And they come out something like this. So these are your magnetic field lines. Ante kada? Yes. So sir, magnetic moment ante, whenever we see magnetic field lines coming from one end and looping at the other end, chuskondi, whenever we have magnetic field lines, something like this. Ide kada? Yes. Hey, what are you writing, sir? I am writing a magnet ra. Chuskondi. This is my magnet ante, this is the north pole of the magnet and this is the south pole of the magnet. Ide kada? Yes. So ante this is having a closed lines within itself. Can you visualize same pattern was forming at some other place also ra? Where ra? Current carrying loop. Nice. Ante if I have a current carrying loop, current I is flowing into it ra. Chuskondi. I ante going down in the back side, coming up something like this. Something like this. So if it is like this, the field lines are again going something like this. Chuskondi. Ide me field lines kada? These are your field lines. Chuskondi. Is it resembling a magnet ra? Yes. So that means if I have a current carrying loop, current is I ra. If I have a current carrying loop, I can replace it with a magnet. Ade. So if I have a current carrying loop, I can replace it with a magnet. And they all act in the same way. So sir, a magnet has magnetic moment. Similarly, this loop should also have a magnetic moment kada? Yes. So for any loop, chuskondi andariki. For any loop, for a loop, magnetic moment m bar is given as I into area vector a bar. Ade. Remember the formula only. I don't want anything other than this. Okay? Magnetic moment is equals to I into a bar. A bar ante area vector. Okay? Good. So sir, if this is my loop, current I is flowing into it ra. Radius is r. Cheppandi. Can I say, sir, magnetic moment is equals to I into pi r square. Direction chepporu okasari. Direction gurinchi maatladalante, you can simply say, sir, it is coming up, going down ante the direction is at the right side. I cap. Ade kada? So I pi r square I cap. This is the direction of your magnetic moment and this is the value. Ante kada? What if you have solenoid ra? Solenoid ante the same thing, but you have n turns into it. N turns ante enti, sir? So first turn, second turn, third turn, fourth turn, fifth turn, sixth turn. So there are n turns. Same ra? No problem at all. Cheppandi. Instead of a single current, there are n currents flowing. So magnetic field m bar is equals to NIA. Ade. So this is your magnetic moment for a solenoid. Okay, okay, yes, 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 good, very good. So this is the magnetic moment M bar. Okay, now let us talk about uh, torque on a loop. So now we are going to talk about చెప్పండి. So we can start with a square loop. Okay, we can start with a square loop. Andari. Yes, depends on the shape of the coil. Ante area ante shape. Chooskondi. If you have a magnetic coil, something like this ray. Okay, this is a circle. Area is equals to pi r square. Ide kada? Yes. If you have a square, then in that case, length L, your area is equals to L square. Your magnetic moment is equals to I into L square. Your magnetic moment is equals to I into pi r square. Leda, if you have a triangle, your magnetic moment is I into A, or else you have a rectangle, again I into A. Depending upon the areas and shapes also. Shape change aithe, formulas also change. Okay? Okay. So if you're changing the shape, areas change. You remember these results, sir. What are the results, sir? For a given length, the circle has the largest area. Okay. Let us quickly talk about torque on a current carrying loop. So when you talk about torque, you imagine this situation, okay? I don't know if you'll understand it or not. This is your magnetic field B bar in the right side. Ante kada? Yes. No problem. No problem, sir. This is your B bar. So let us imagine this was our loop. This is my loop, length ante L, length ante L, length ante L, length ante L. I usually take rectangle when I'm explaining this for JEE students, but now we will take with a square. The length is L. Your chapter weightage, you can at least expect 2 to 3 questions, 8 to 10, 12 marks easily. 8 to 12 marks are from this chapter and EMI. They are twin chapters. Magnetism and EMI are twin chapters. 2 to 3 questions easily you can expect. If you combine with the two chapters, 4 questions is the minimum that you can expect. So what I'm doing now is I'm changing this shape a little. Ante this is the axis. Chooskondi. I'm changing it a little. What should I tell you? You see, okay? You see it. So this is your loop. Okay, this is your loop. This is your magnetic field direction. This is your magnetic field direction. Ante kada? Now I'm twisting it little. Twisting ante enti, right? You twist something like this. Are you understanding? You are twisting this loop a little, something like this. What will happen? Because you have twisted, there will be a restoring torque. Chooskondi. Twisted ante ela ravalira. How should I write it? So after some time, my loop looks something like this. Are you understanding? It has been twisted by an angle of theta. Chooskondi. This angle is theta. the angle is theta. Here also angle is theta. And here also angle is theta. Are you understanding? I've just twisted it a little. Are you understanding? When you have a loop, when you twist it a little, automatically there will be a restoring torque. Okay? Sir, restoring torque ante we are talking about I don't know if I should tell you this or not, but I'm just quickly going through the proof of it. Okay? Chuskondira. Let us say the current I is flowing something like this. Ekkada kuda current I flows, here also current I flows, here also current I flows. For 5 minutes, ekkada nunchi oka for 5 minutes from this point, the students who can understand the proof focus. The students who think that they are weak, ignore for 5 minutes. Okay? Chuskondi. As it is going in the bottom direction, your current is upward side and your magnetic field is towards the right side. Chuskondi. Your force L bar cross B bar kada, your L bar cross B bar, L bar cross B bar, your L bar cross B bar must be acting towards the right side. Chuskondi. Your force F bar. Ide kada? Yes. So I have lifted it up, I have lifted it down. Chuskondi. So your L bar cross B bar, hey, L bar cross B bar. What I'm telling you, what I'm telling you, something like this, right? Your L bar is upwards, your B bar towards the right, and L bar cross B bar should be into the plane of the paper, something like this. So what happens is ultimately I'm telling you this should be into the plane, and here the force L bar cross B bar, cheppandi, L bar cross B bar into the plane, L bar cross B bar, hey, same ra. What are you talking, right? And when it comes to this point, chuskondi, your L bar is coming out of it and your L bar is going into the plane of it. You remember the torque ante telusara, torque ante entira, torque is R bar cross F bar. Ide kada? Yes. So your torque on this line and this line becomes 0. Because the force is acting along the line of the force in the two edges. The only force or the torque that is left is in the two ends of this wire. For now remember, sir, net torque is equals to M bar cross V bar. Just this is a formula. M bar ante entira, I into A bar cross V bar. Ide kada? I is what, sir? I is current. Area is, sir, length square cross B bar. So this is your net torque on a current carrying loop. Formula gurtupettukondi. I don't want to make it much complicated by going into the proof of it also. You just understand, you remember the formula. Already you might be having a lot of headache. Sir, biology also, sir, chemistry also. Also, we are not the good at mathematics, sir. Why are we telling all these things? If you were JEE students, I would have told you the shocking things. Anyways, net force is 0. Yes, net force becomes 0, but net torque is not 0. In the way, it's always a loop. Kada? Yes, net force is 0, but net torque is equals to M bar cross V bar. Choose. Hey, do you remember something? Torque on a dipole. Torque on a dipole. Torque on a dipole placed in the external electric field. Sir, dipole unte, this is your plus Q charge, this is your minus Q charge, sir. This was my dipole. Hey, should I write it here? Okay, so if you rotate it by a little angle theta, sir, again it was having a restoring torque. Tau is equals to P bar cross E bar. Choose the similarities. M bar cross B bar, P bar cross E bar. Here M is magnetic moment, dipole moment, magnetic field, electric field, torque. Other. Okay. You tell me, all of you, if it is understandable or not. Perfect. So now let us try to take some PYQs also. ఒకసారి లైక్ చేసుకోండి ఈ వీడియోని అందరికి. I'm observing that you are making me so disappointed by not liking the video. So thus I'm telling you 2025 question ra. It's a very classic question of your velocity selector. If you have understood velocity selector, this question is a piece of cake for you. Chuskondi, the two options are going to get cancelled. Which two options are either perpendicular or parallel? Ade kada. What is the condition in velocity selector? Gurtunda, velocity selector low, you have the two plates. Electric field was up to down, top to bottom kada, yes. And your magnetic field was into the plate. if you want no deflection, you understand electric field downwards, magnetic field inside ra. They are perpendicular to each other. Ade kada? Yes. Electric field downward, magnetic field inside ante they must be perpendicular ante the parallel options are gone. It cannot be parallel. Ade. Electric field must be perpendicular to the magnetic field. Are you understanding? Then and only then the conditions could be balanced. Ide kada? Yes. Now you only have to talk about the value. Forces should be same. Electric force should be equals to magnetic force. Ade kada? Q gone. Your E should be equals to V into B ra. B value enti ra. B value is equals to 9 into 10 to the power minus 4. Ide kada? Multiplied by your V ra. V is how much? C by 100. Ante 9 into 10 to the power minus 4 into C value entara 3 into 10 to the power 8 divided by 100. Ide kada? Yes. So sir, 27 into 10 to the power 2. Perpendicular to V bar. It's a very simple question. Okay. With that being said, we are good to end this chat. Yes, we are good to end. You also know the value of speed of light. Okay, chala important. It has not given in the question, but that means you must know the value of speed of light. Okay, good. Not D. How D? Should be 2 now. So it's minus 4. It's minus 2 becomes minus 6. 8 minus 6 becomes 2 only. Kada? So it should be equals to 10 to the power 2, not 10 to the power 4. Okay, yes. So your chapter magnetism has been completed. Although there are a lot of things to discuss, but not there for you. They keep significance only for JEE students. Okay, so if you don't have any doubts, can we end this session? Andariki cheppandi okasari. Your time is 8:14 kada? Yes. Problems we will take it separately ra. Chuskondi. Your syllabus complete అయిన తర్వాత my target is to finish your entire syllabus by the end of February. March, April ఈ 2 months ని we will only be focusing on the PYQs. చాలా PYQs రా. 4, 5 hours PYQs we will be taking. Yes, we will be taking the PYQs and we will be completing all the PYQs until last 20 years ki PYQs. I will take one by one question in the lectures itself. If it goes 4 hours, 5 hours, it's good. Before starting the PYQs, I request all of you to make a formula sheet. Then you can start. Okay, good night Andariki, good night. Good night Nana. All of you have a very safe nights and wonderful journey ahead. Thank you so much. Parimala. Good night. Good night, all of you. Good night. Bye. Okay, so I'm ending this session here. Let's meet tomorrow. Tomorrow we'll be completing gravitation. Okay, gravitation one shot completing. Okka lecture lo we'll be finishing the gravitation. So the lecture starts at 2 p.m. tomorrow. Andariki. Repu lecture is at 2 p.m. Gravitation one shot. Okay. Yeah. I will give you the PDF. Don't worry. Okay.